I'm Sammy.
And I'm Alex.
And you're watching
The Lab Report.
Every reaction causes a change in temperature in both the products and the surrounding environment. This is known as a change in enthalpy. In this lab, the challenge was to create a hand warmer that heats up by 20 degrees Celsius. Only 10 grams of 7 given compounds could be used. The solution had to be as cheap, fast, and environmentally friendly as possible. We hypothesized that lithium chloride would make the best hand warmer because it releases the most energy per gram dissolved. This exothermic dissociation reaction releases 0.882 kilojoules per gram of lithium chloride.
To test how much energy compounds release or absorb, the compounds are added to a styrofoam cup calorimeter with a beaker inside. A thermometer is placed into the calorimeter so that the temperature can be read from the outside. Our strategy was to first test a small quantity of an exothermic compound. We used sodium carbonate and compared theoretical change in temperature to the actual change in the temperature. Using this percentage, we determined how much lithium chloride to use in order to get a 20-degree change in temperature. Then, we calibrated the results to take into account the specific heat of the calorimeter and the amount of energy absorbed by the styrofoam. In our procedure, we added the compound to the calorimeter, which also held 50 milliliters of water. With the thermometer inside the calorimeter, we swirled it until the thermometer peaked at its highest temperature.
Our test run with sodium carbonate resulted in a temperature change that was 66% of what we had predicted in our calculations. This means that the percent yield in this experiment was 66%. Therefore, 7.175 grams of lithium chloride would give us a change in water temperature of 20 degrees Celsius. The chemical reaction had a change of 19.9 degrees Celsius. This reaction took 10 seconds, and the amount of lithium chloride used cost 47 cents. Keep in mind that it wasn't until after we had conducted the experiment that we realized that the results had to be calibrated. After calculating the specific heat of the calorimeter, the lithium chloride produced enough energy to raise about 50 milliliters of water 39.7 degrees Celsius.
In our data table, our hand warmer created a larger increase in temperature than the mean. It was faster, but it cost 1 standard deviation more than the mean.
Spending more money on making a hand warmer generally led to a more accurate change in temperature. There were a couple exceptions where groups achieved a 20-degree change for a very small price, 11 cents being the lowest. A large cluster of 20-degree changes cost around 50 cents. One group, Group 3 of A period, took 222 seconds to complete their reaction, and we removed this data point from the class data. This point is an outlier because it is more than 3 standard deviations from the mean. All but 2 other groups completed their reactions in less than 75 seconds. For the most part, longer reactions raised the temperature more than shorter reactions did. Here, the same outlier was removed as in the last graph. Data closer to the origin makes a better hand warmer because it is cheaper and reacts faster. However, most other groups could not accomplish both a cheap and a fast hand warmer. The majority of their reactions took 15 to 60 seconds. Within this time frame, there is a large variation of cost. All reactions that took longer cost around 50 cents.
There is a very common misunderstanding within many of the groups about what value to report for the change in temperature. When a reaction takes place within a styrofoam calorimeter, it is not a perfect calorimeter, so some of the heat is absorbed into the styrofoam. This means that the reading on the mercury thermometer does not include the energy absorbed by the calorimeter. In order to calculate the change in temperature of a hand warmer, the amount of energy absorbed into the calorimeter must be added to the change in temperature of the thermometer. Because of this common error, many reported values are actually much lower than the actual change in temperature of the hand warmer. One experimental error in the lab was our method of calculating a percent yield in the experiment. This step was unnecessary because we adjusted to the specific heat of the calorimeter at the end. After running a test trial with the sodium carbonate, the temperature reading on the thermometer had only increased by 66% of the predicted value. What we didn't realize until after we had conducted the experiment was that some of the energy released in the reaction was actually absorbed by the calorimeter. Because of this error, we adjusted for the percent yield, increasing our starting mass of lithium chloride. This led to a much higher change in temperature. Our change in temperature was 39.7 degrees Celsius, which is 122% above the class mean of 17.9 degrees Celsius. Another error is the inaccuracy of the mercury thermometers used. The height of the mercury never stays still. It is constantly fluctuating. Also, it is very difficult to know when the reaction has stopped releasing energy. This makes it difficult to get an accurate reading of the thermometer when the temperature has peaked. leading to slightly skewed results.
If we were to do this experiment again, we would test out the effects of combining 2 or more compounds in the calorimeter to create a precipitation reaction. This precipitation reaction would have the lowest cost possible. Another idea of a new experiment would be to test endothermic compounds to see if they could release enough heat when they solidified into solids to raise the temperature by 20 degrees. Sodium acetate is one example of a compound to test. Finally, we would redo this experiment without calculating and adjusting to the percent yield in the beginning, giving us a much more accurate change in temperature for our hand warmer. These are our sources. Thank you.
Thank you.